dear students. So today we are starting our next chapter, chapter 19, differentiation. Okay, so I am taking those chapters which are important for the next class. Okay, that means for your next 12th standard. Okay, so differentiation is an important chapter. Okay, you need to identify the differentials of derivatives of some functions. Okay, functions such as trigonometric functions, algebraic functions, like that. Okay, you have taken the derivatives of algebraic and functions like that. Okay, so let us start the chapter differentiation. So differentiation, that is incremenent. You know about the name incremenent. What is incremenent? Yes, we have studied changes in the values of y corresponding to small changes in the values of x, where y and x are related to each other by the equation y is equal to f of x. Y is equal to f of x is a function, and y is equal to f of x means y is changing. Okay, by the values of y is changing corresponding to the values of x. That is the equation y is equal to f of x means. So if we take y is equal to x cube, we get when x equal to 2, we have y equal to 8. So that kind of values are functions are y is equal to f of x. Okay, that is, which means last sentence is that it should be noted that delta x is not the product of delta into x. Delta and x, delta is x is not a product of delta and x, but merely a symbol. It's a symbol for the change of x. So delta x means it's the change in x. Okay, and it doesn't means that delta and x are multiplied together. And then the increment of y is delta y or delta y. Two type of notations are there. That's increment. Increment means the change in a variable. That is increment. Okay, yes, that's the increment section. And incremental ratio, that's also not very important, but it just you have to know about the terms. Incremental ratio is, yes, that is delta y by delta x equal to f of x plus delta x minus f of x by delta x. That is the incremental ratio. Okay, that is it. That is the limit. That means the limit of a function. That is also the incremental ratio or difference coefficient. Delta x y by delta x equals f of x plus delta x minus f of x by delta x. That ratio is the incremental ratio. Okay, yes. And derivative of a function, that's very important. What is a derivative of a function? So we have taken the differential coefficient delta y by delta x, the limit of the ratio delta y by delta x. That's the told you earlier that yes, it is the derivative. We have taken the limit of that delta y by delta x. Incremental ratio, we have taken the limit of incremental ratio, and as delta x tends to 0. As delta x, you have studied limit functions in 10th standard, I think. Okay, so that is the, as delta x tends to 0, delta x approaches to 0, that the limit may or exist or may not exist. That is the derivative. If the limit exists, that is the derivative, which is the definition, which is very important. Let y is equal to f of x be a continuous function of x, then limit delta x tends to 0, delta y by delta x, that is limit delta x tends to 0, f of x plus delta x minus f of x by delta x. That ratio is the differential coefficient or the derivative of f of x with respect to x. It's denoted by dy by dx. So derivative is denoted as dy by dx or d by dx of y, or dy y dash f dash x, or d by dx of f of x. These are some symbols that has used to denote differential coefficient or derivative of x with respect to x. Okay, I think all of you get it. Okay, that is the derivative of a function, which is very important. That definition should be studied very thoroughly. Okay, it is very important to in the next chapter, next year also. So dy by dx is the derivative, and caution and remarks are given. Just read it. Okay, that's not important, but just read it to understand what is given. Okay, then derivative of fx at the point x equal to a. If a point x equal to a is given, what is the derivative of the function? So the derivative of a function y is equal to f of x with respect to x, and that point is at x is equal to a, which is defined as limit h tends to 0 f of a plus h minus f of a by h, provided the limit exists and is denoted by f dash of a. So f dash of x is denoted as a derivative. So if that x is a, then what is the limit? So limit h tends to 0. H tends to 0 means delta x is h here. So limit h tends to 0, f of a plus h minus f of a by h. And a function is said to be derivable or differentiable at x equal to a. We can say that a function is differentiable at a, then it should have a derivative there. If it has a derivative there, a function is said to be differentiable on an interval if it is differentiable at every point of the interval. Okay, that is very important points there. Okay, that should be studied very well. Okay, yes. And for existence of a derivative, the limit must be the same whether h approaches 0 from the right or from the left. If these limits are different, the derivative will not exist and the function will be not derivable. Okay, if we take the left limit and right limit, if those two limits exist and they are equal, and they exist, it is differentiable. But the left and right limit does not exist, the function is not derivable. Okay, yes. Next is the function is not derivable, that is f dash x is not exist. The left-handed or right-handed limit does not exist, or both exist but have different values. So if it is not derivable, the limit does not exist and also the limit are not equal. Okay, so that is the condition, and there is an equation and there is an example given. F of x is 3 plus x by 3 minus x and x not equal to 0. We have to find f dash of 2. F dash of 2. For that, f dash of 2 is limit h tends to 0, f of 2 plus h minus f of 2 by h equals limit h tends to 0. You have to put x 2 plus h replaced by x. So it becomes 3 plus 2 plus h minus 3 minus 2 plus h minus 3 plus 2 by 3 minus 2 by h. It becomes 5 plus h by, that is 6h by h into 1 minus h, taking the LCM. And then limit h tends to 0, 6 by 1 minus h, that is 6 is the answer. So the limit f dash of 2 is 6. Clearly, yes, that is how will you find the f dash of t2. And the another question is given. I think it is also clearly given for you. Please check it. Next is the physical interpretation of the derivative. It's just given for you as an interval. Okay, physical representative means in terms of displacement and displacement time, that's given, measure is given. You just read it. Okay, it's just not important, but just for information it is given. For your knowledge it is given for you. Please read it. Okay, and next is the geometrical representation of dy by dx, which is important. Okay, what is the geometrical representation? Okay, you just go through the graph. Okay, the important part is dy by dx is tan psi. That notation or Roman numeral is psi. So tan psi is equal to slope of the tangent at P xy. P is the point, xy that is given. Okay, look at the graph. X-axis and y-axis is given. OMN is along x, and a graph y is equal to f of x is the function there. Okay, taking the slope P of xy in the slope of the tangent is given like that. Okay, read the information given and then study. The main point is dy by dx is equal to tan psi. Okay, which is important geometrical representation of dy by dx. And next is the differentiation principles. Okay, so how will you differentiate? The first principle is put the function to be differentiable equal to y, and then find the delta x increment corresponding to the value that y plus delta y is equal to f of x plus delta x, and then subtract delta y from 1 and 2. Yes, this above equations, and you will get delta y is equal to f of x plus delta x minus f of x, and take delta y by delta x, the ratio, and then apply limit delta x tends to 0 on the both sides. Okay, that is, and the above process of differentiation is called differentiation from definition or from first principles or the delta method. Okay, yes, this is the delta method, differentiation from definition or from first principles, which is important. Okay, yes, and with respect to this, examples has been given for you. Okay, please look at this and study the examples. Okay, these are the worked up problems. Please go through this. This is also the same, and try to study the d by dx of x square. What is x square? Root x 1 by x cube root of ax plus b, and ax plus b by ax plus d. These 5 equations are algebraic functions. Okay, so please study the differential derivatives of this function, which will be helpful for your next year chapters. Okay, please do study this. This next is d by dx of root x is 1 by 2 root x, which is very important. And then y is equal to 1 by x cube, that is minus 3 by x raised to 4. And then d by dx of root of ax plus b, that is a by 2 root of ax plus b, that is d by dx of root of a linear function is 1 by 2 that linear function into coefficient of x. Okay, that is given there. And also d by dx of ax plus b the whole raised to n, which is very important one, n into ax plus b the whole raised to n minus 1 into a. That is the derivative of a binomial function. It's a binomial series, so that is n into ax plus b the whole raised to n minus 1 into a. Yes, that's very important. And d by dx of dy by dx is equal to d by dx of k into f of x. K is a constant there, so k into f of x is k into that constant is taken out, k into d by dx of f of x. That is also important. And then very important one, the theorem 4 is given. The differential coefficient of the sum of two functions is equal to the sum of differential of the coefficient of these two functions. That is d by dx of u plus v is d by dx of u plus d by dx of v. Okay, very important one. And similar to according to these type of problems, okay, we just give earlierly study. Please do this workout, these exercise problems also. Okay, next is the rule of differentiating product functions. If two functions are given as product, that is d by dx of u v, earlierly it is the sum, here is the product. Okay, that is first function into, that is given each function's derivative each other. U into dv by dx of u into v is u into dv by dx plus v into du by dx. First function uv is, first function is u and second function is v. U into first function into derivative of the second plus second into derivative of the first. That is a very important theorem. Okay, this is very important theorem. According to this, two questions has been given for you. Okay, x square minus 4x plus 5 into x cube minus 2. Here is the first function is x square minus 4x plus 5, second is x cube minus 2. So the u into v. So u into dv by dx plus v into du by dx, that is x square minus 4x into d by dx of x cube minus 2 and x cube minus 2 into d by dx of x square minus 4x plus 5. Okay, yes, and the derivative is find out. Similarly the next questions. And next is the quotient of two functions, derivative of the quotient of two function u by v, that is v into u du by dx minus u into dv by dx by v square, that is denominator into derivative of the numerator plus minus numerator into derivative of the denominator by denominator square, that is the that is derivative of the quotient of two function, which is also very important. So you have to study the sum, product and quotient of two functions. Okay, these derivatives should be remembered. Main problems are you have to solve the problems similar to these type of questions. Okay, and a summary is given. The derivative of trigonometric function, you have no trigonometric functions, you have studied earlier sine, cos and tan. So what is the derivative of sine, cos, tan, cot, sec and cosec? This should be remembered. You have to be by heart this, because these should be remembered very well. Okay, for differentiating functions this should be remembered. So the derivative of sine function is cos, derivative of cos function is minus sine, and derivative of tan is sec square x, derivative of cot is minus cosec square x, derivative of sec is sec x tan x, and derivative of cosec is minus cosec x cot x. Okay, this is very important. Please study the differentiation of trigonometric functions also. Okay, clearly given for you, study very well. And also these are some main points. D by dx of x is 1. Okay, d by dx of ax is a, and d by dx of x raised to n is n into x raised to n minus 1. Okay, they should be remembered. And derivative of a constant is always 0. Derivative of a algebraic function x is 1, and also derivative of a kx constant into x is k into 1. Okay, yes, please do these type of problems also, then you can very clearly understand it. Okay, and this should be remembered. Please do study this also. Logarithmic function and exponential functions. So d by dx of e raised to x is e raised to x. D by dx of log x, ln is ln x means log x is 1 by x. D by dx of a raised to x is a raised to x log a. D by dx of x raised to x is x raised to x into 1 plus log n and log x. And last is d by dx of log x to the base a is 1 by x into 1 by log a. Okay, these should be remembered also. Problems will be there for derivatives. Last is sum. This is the last exercise you have to be studied. This is all our trigonometric functions has been given. So first is sine 5x. So what is the derivative of sine? It is cos. So d by dx of sine 5x is cos 5x into 5. Cos 5x into 5. Yes, the coefficient of x. Okay, so it is 5 cos 5x. Okay, I think it is clear for you. So all types of problems should be done like this. Okay, so this is the last portion. So you have to be studied all the derivatives. The last 3 pages are very important. Please do study that, and also the definitions of how to differentiate sum, product and quotient. That's also important. And the increment, how will you differentiate? The limit, how will you find the limit of a function? That are the important topics in this, important sections in this chapter. Please write these all in your notebook and do the exercises and workout problems that is given in this chapter, in this class. Okay, I think you have all have textbooks. Please do work out the textbook solved out problems. If you feel any doubt, please ask me, I will clear it for you. Okay, I think all of you understood the topic which is given for you today. Okay, and I will taking one more chapter in for this for your future year, that is probability. Okay, that is also important for you. So these two chapters that I will taking for you in this week. Okay, so I'm winding up this year by taking these two chapters. That is important for you. That's why, because we have not time, and also the council has reduced the syllabus, okay, for you. So I have taken those chapters which are important for your next year, that is the council says. Okay, so I have taken these two chapters in this week. Please, you do the problems. If you want a class or live class, please inform me also. If you don't understand these two chapters, this is very important. So if you have any doubt in this, please do that. And if you feel any doubt, please clear out before the next Tuesday, I mean March 2. Please do that. Okay, and after 2 I will posting the revision questions for you in EduPro. Please do that also, work out that problems also. Okay, so I will. Okay, that's all. Okay, thank you for today's class, and I hope all of you understood this. Okay, I'm winding up. Thank you, students. Have a nice day.